The last topic that I will discuss today is motion in a circle, and specifically motion where your speed is unchanging. Your direction is of course changing because you're moving in a circle, and so your velocity is changing, but your speed is unchanging. Remember that conundrum we discussed earlier. So this is called uniform circular motion, moving in a circle at constant speed. So here's a circle, or something close to such, and you're moving at a certain speed. Let's see, we used reddish for velocity before. So let's say we're going this way. That's velocity. And at this point, your velocity is this direction. And at this point, your velocity is in this direction. Of course, all these arrows are ideally going to be the same length because the magnitude of your velocity is unchanging. It's only your direction that's changing. All right, so this is the scenario that we have. And in order to produce this motion in a circle where your speed is unchanging, what must your acceleration vector look like? If we had an acceleration vector that was like this, right? This is 90 degrees, but it's not. That means we'd be speeding up because there would be a parallel component to your acceleration as well as a perpendicular one. So you're changing direction, but you're also speeding up, right? So that must not be it. If your acceleration were back here like this, right, then you'd be slowing down. Yeah, there's a perpendicular component to your acceleration, so you are changing direction, so you might be traveling in a circle, but there's also this parallel component, and by parallel I mean it's parallel to your velocity at that point, and so that means that you'd be slowing down, right? So there's this parallel component and it's in the opposite direction from velocity, so it's taking away from your velocity as time goes on. So that must not be it either. And we kind of talked about this before. But if your velocity is such, then your acceleration must be exactly perpendicular, right? That's 90 degrees, exactly perpendicular. And this is your acceleration, and specifically it's radial acceleration. So a rad, radial acceleration. So I'm going to draw all these in here. And if you have radial acceleration, there is a couple equations that are useful. Or rather, if you have uniform circular motion, there's a couple equations that define radial acceleration that are useful. And this circle has radius r here, like this. Do straighter, because I'm finicky like that. All right. So this is our scenario here. So if you have this type of motion, then there's a couple equations that would make your life a little easier. So a rad is equal to v squared, the magnitude of your velocity, which is unchanging, divided by r, the radius of your circle. Notice you don't have to move in a complete circle, right? You can move in just part of the circle, but as long as the radius is unchanging as you move around the circle, then it applies to that segment of your motion. The other one is if you have the period. So period is the time that it takes for one revolution, and we give it symbol capital T. So period is the time for one revolution around your circle in seconds. And so A rad is equal to 4 pi squared r divided by the period squared. So those equations make your life a little bit easier if this is the case. All right. So there's one more topic in this chapter, which this lecture is based off of, and it's the same in many, many introductory texts, yours and others. And so I feel compelled to tell you to read this, but it is not something I'm going to lecture on. So it's relative velocity, and it's just a couple paragraphs. I'm going to tell you to read this. Read it in your textbook. Right after you're done watching this video, just crack it open. It's 2 to 3 paragraphs. Read it. It's fascinating. It really applies to some later chapters a little bit for us, and it applies to later classes in physics that you may or may not be taking, and you may or may not be interested in regardless of whether you're taking it. Physics is fascinating. So relative velocity, it just kind of talks about your velocity changes depending on the observer. And then read the entire chapter as well. So the workflow for this class, I think should be, one, skim the chapter, right? Read the chapter in the book that the lecturer is referring to, is going to be covering that day. You don't have to read it with a dictionary or an encyclopedia side by side and Googling every single term, but just read the chapter, familiarize yourself with the topics that are coming, and if something doesn't make sense, don't worry. See if the lecturer will fill it in for you. Then watch the lecture. And do it taking notes. Right? Taking notes. I broke the lectures up into small digestible pieces that are all labeled so that you can go back to certain topics, but there might be something within a video, and the video might be an hour long, like the last video, where you would want to just look at your piece of paper of notes and you'd be able to find the answer in 2 seconds versus scrubbing through my video trying to find when I covered what and whatnot. Then after you watch the lecture, don't go right to the homework. Don't go right to the homework. Then read the chapter, right? I will say even more than that. Seriously read chapter. Okay? This is when you really read the chapter. At first, you're just skimming it. You're reading it over your bowl of cereal or your cup of coffee, right? And at the very least, you are looking at all of the topics and looking at the pretty pictures and seeing where we're going. You watch the lectures, then this is when you are seriously going to read the chapter. Make sure you understand everything. If you come across a paragraph that you don't understand, you don't have any idea what it's talking about, read it again. Read it again if you need to a third time, or go back and watch the relevant part of the lecture and see if I cover it. Or send me an email asking me what the heck is up. I don't understand this part at all. This sentence specifically, what is it talking about when it mentions instantaneous velocity? What does that mean, you know? Then this is when you do your homework. I will say do problems. If you really want to master the content, and if a chapter is particularly hard for you, it might take doing more than the homework for you to be able to really get down the topic. Because really the ultimate test is the test. That's why we call it such. So just because you can do the homework, or just because you can find some obscure likeness to the problems in your homework online and you can get by with the passing score on your homework, doesn't mean that you've mastered the content. So be honest with yourself and don't leave the topic until you feel you have mastered it, because at the pace of this class, we're going very fast. You will have very little time to go back and master. You are studying for the test to just be a review, and you want to have previously mastered the topics. So if you follow these 4 steps, I believe you will have success in this class. If you're skipping any of these steps or not doing one of the steps to the honest fullest that you need to, then you know where you need to improve if you're struggling in the class. I'll see you next chapter. We talk about Newton's laws, and it's a very exciting foray into physics.